Hi, let us continue our discussion on Boolean algebra. Last lecture we have seen up to question number 9 in the classroom workbook. Now let us see the next question, question number 10. The chapter 2 classroom workbook, question number 10. Please read the question. Right. In the TTL circuit shown in the figure is fed with a waveform shown in the figure. All the gates have equal propagation delay of 10 nanoseconds. So each gate is having a delay of 10 nanoseconds. He has given X, he is asking the Y circuit. Let us plot it. Here, if we take here X, what is this X bar? Again X bar whole bar is X. But in between there is a delay of 10 plus 10. How much? 20 nanoseconds. Okay. So, let us take it as some X1. What is X? This is X and this is X1. Both are input to the XOR gate. So, what is X1? X1 is same as X, but there is a delay of how much? 20 nanoseconds. There is a delay of 20 nanoseconds. Right. Now see here. I'm sorry, one moment. This is 20 nanoseconds. Right. Now, if you perform these two XOR operation, this is X1, right? My X XOR with X1. What is X XOR with 1? Both are same, your output is 0. Both are different. What is the output you will be getting? 1. Again, both are same, your output is 0. Both are different, you get output equal to 1. So this is one of the important application of XOR also. Not here. Generally, XOR and XNOR can be used for phase difference measurement. When both are same, identical, here you get 0. Both are different. Whenever there is a relative phase shift, you will get the output equal to 1. Okay. That can be used for measuring phase shift in the periodic signals. Now see here. This is what we are expecting, but Y is also having, what is Y? What is X1? Delay X by 20 nanoseconds. What is X XOR X1 without delay? Y is equal to X XOR X1 with 10 nanoseconds delay. So here, this output you shift it by little time. This is what you get it. This is the original output you are getting. See the options. Option A will satisfy your condition. Okay. So this is a simple. X is given. Delay X by 20 nanoseconds. Both are XOR operated, both are different, you get 1, both are same, you get 0. Then after that, at the Y, this is the output you are getting. Now you can see here in this, just delay by 10 nanosecond, because XOR gate is also having delay. So just little shift, waveform will not change. So this is what given by output. So option A, copy it. Now let us see question number 11, which you can answer easily. If the output of a logic gate is 1 when all its inputs are at 0, the gate must be NAND NOR and XOR XNOR OR and NAND. What is the answer? NAND and NOR. When in both NAND and NOR gates, when both the inputs are zeros or all the inputs are zero, your output is equal to 1. So what is this? Option A, which you can answer easily. Next question. 11th is answer A. 12th question. The output of two-level AND OR gate network is F. What is the output when all gates are replaced by NOR? Please listen. AND OR is equal to NAND NAND. Here NAND is replaced with NOR NOR. Or if you have here function F, this will be function dual, because NOR is equal to OR AND, which we discussed earlier. So AND OR is equal to NAND. Similarly, NOR is equal to OR AND. So he is replacing AND OR with NOR, or indirectly he is replacing AND OR with OR AND, because NOR or OR AND both are same, which we discussed in the two-level logic. So AND OR replaced with NOR means we are replacing it with OR AND. AND OR replaced with OR AND, function is replaced with its dual. So option C. Question number 13. Which of the following statements is correct? For a 4-input NOR gate, when only 2 inputs are used, the best option for unused inputs. We discussed in the starting, what is the best option for unused input? To connect to any of the used inputs, to connect to enable input, floating, depending on the logic family. All these options I have given. In that, what is the best option is connect to enable input. For NOR gate, so what is the answer? Connect to enable input. So for NOR gate, what is enable input? 0 is the enable input. If it is NAND gate, 1 is the enable input. For NOR gate, 0 is the enable input. So what is the answer? Connect to ground. Option A. This we discussed starting. Unused inputs, how to treat. Okay. So what is the answer? Connect to ground. 0 is the enable input of NOR gate. Okay. Next, 14th question. In the 14th, what is the statement? Which of the following statements is correct? Static 1 hazard may occur in 2-level AND OR. Static 0 may occur in AND OR. Dynamic hazards occur in 2-level OR AND. Essential hazard may occur in combinational. So what is the first option? Static 1 will occur in AND OR. This is right answer. Static 0 will occur in AND OR. No, in a properly formed AND OR logic, there is no static 0 hazard, we discussed in the class. Next, dynamic hazard, it occurs in multi-level combinational circuits. Essential, sequential, it will occur. So what is the answer? Option A. Static 1 hazard will occur in AND OR. Now let us see question number 15. Read the question. Right. It is very easy. As we discussed earlier, whenever a figure is given like this, what I told easiest way is send the bubbles back to cancel the bubbles. So you can send these bubbles backside or this bubble backside, doesn't, it depends on your convenience. If you send here, 4 bubbles will cancel. Okay, then replace this, because try to cancel more number of bubbles. So you can replace this NAND with a bubbled OR gate. This NAND can also be replaced with a bubbled OR gate. Then this bubble cancel with each other. Then what is the answer? P, Q, R, S. So it is P plus Q, R plus S. Now what is the output? P plus Q into R plus S whole bar. Okay. If you want, you can apply De Morgan's law. Then it is option D is given, right? Directly take it. P plus Q into R plus S whole bar. Okay. So it will make our analysis easy by cancelling the bubbles. It will make always our analysis very easy. Option D, P plus Q into R plus S whole bar. According to option, whichever is given, we should write in that particular format. You can apply De Morgan's and write it as P plus Q whole bar plus R plus S whole bar, or P bar Q bar plus R bar S bar. That can be done, but whatever given in the option, we should take it. This is the given in the options. So always don't write the total equation. Cancel the bubbles, which will make our analysis easy. Copy it. Copy the question number 16, read it after this, after copying that. Right. We know B XOR B equal to 0, or B XOR B XOR B equal to B. This is for odd number, this is for even number of B's. We know this when we discussed the XOR gate. In the question number 16, now read it. What happens when the bit string is XORed with itself n number of times as shown, not regularly n number of times, it is as shown in the equation. Here you observe, this is n times. Here extra how many? 3. Total how many? N plus 3 times. Now you understand, if n is odd, n plus 3 is even. What is the answer for even? 0. If n is even, my n plus 3 is odd, then what is the answer I will get? B. Now see the options. Is it clear? Total how many number of times he has done? N plus 3 times. So n is odd, n plus 3 is even. N is even, n plus 3 is odd. Now what is the options? Complements wrong. Complements wrong. Divides by 2 power n wrong. Remains unchanged when n is even. So when n is even, n plus 3 is odd and the output remains unchanged. Okay, copy it. Next question. 17th question. The simultaneous equations on the Boolean variables x, y, z and w have the following solutions for x, y, z, w. See here, a simple logic. What is the second condition given by examiner? One moment. Seventeenth question. See, he has given all conditions, but see simple one important condition, x, y equal to 1. What is the meaning? X equal to 1 and y is equal to 1. You see the options, only one option is satisfying x and y both are 1, that is option B. So don't waste much time here. He has given four equations. In that one equation is saying x, y equal to 1. X and y both are 1, then only it is possible. So x equal to 1, y equal to 1. Then what is the answer? Option B is the only option which is satisfying x and y both are 1. So option B. Right. Question number 18. Please read. Consider the following gate network. Which of the following gates is redundant? Right. Please see here. This is W bar. This is W bar X. And this is X bar YZ. Here directly see. If you add these two, what is the equation? Because what is the output? W bar plus W bar X plus X bar YZ. Now see, W bar you can take common. What is the answer? W bar into 1 plus X plus X bar YZ. 1 plus anything is 1. So W bar plus X bar YZ. Okay. So what is the condition? Now see here. W bar plus X bar YZ means this gate is not required. So what is the gate number given for that? Gate number 2 is redundant. Redundant means it is not necessary. So which one? Option B. This is not available in your output expression. Copy it. See here. In the question number 19, he has given the Venn diagram. He is asking the expression for this. Before going to this question number 19, let us have some basic understanding. See here. Suppose in this Venn diagram, this is indicating A. This is indicating B. This common area between them is also called as A intersection B or A into B. This white area, which is only this part, this is in only B exclusively but not in A. This is called as B but not A, B into A bar. Similarly, this white area which is in A only but not in B, that is A into B bar, A but not B. Total is this plus this is called A union B or A plus B, A or B. So common area is both A and B. Total area is A plus B. Only in A but not the remaining B, B but not remaining A. Now see here. This is just for your understanding purpose. Now this common area is called A into B. This one. This include ABC, but it is AB plus ABC is again AB only. Now what about this area? This is exclusively in C but not in the remaining. What is the remaining is called A plus B. So you can say it is in C but not in A plus B. So not in A plus B means A plus B whole bar, that is C into A bar B bar. So what is the answer? AB plus A bar B bar C. So this is AB. This is in C only but not in A or B. That's why this is in C only but not in A or B. So C into A plus B whole bar. This can be written as C into A bar B bar. So AB plus A bar B bar C, which is option D. Take it. Right. Same model, one more question is there. We'll see question number 20. Right. Let us read question number 20. The Venn diagram representing the Boolean expression A plus A bar B is. What is A plus A bar B? By distributive property, it is A plus B, absorption. A plus A bar B equal to A plus B. So just now we discussed for A plus B, what is the Venn diagram? This is A and B. Total should be shaded, either A or B. So which figure is having this? That is your answer. Which figure is having this? Option A. Option A is the answer. Now you can see option B is A into B. Option C is, it is not in A plus B, that is A plus B whole bar. Option D is the total, that is 1. So what is our answer? A plus A bar B is A plus B. This is the A plus B Venn diagram. Totally this, that is option A. Copy it. Right. After that, read question number 21. See, in the 21, what is the statement given by examiner? Which of the following gates is redundant? How to find? See here. What is the output expression here? This is x, y bar, z. This is w bar, yz. This is w bar, xz. So which is equal to x, y bar, z, w bar, yz plus w bar, xz. Now here one way is to draw the K-map and find the redundant, one method. Another way is find, is there any consensus law here? Yes, x is present. Here also x only. Yeah, here y is present, here y bar is present. Y bar. And the remaining, whatever you have xz and w bar z ka product is here. You can neglect. So what is the answer? X y bar z plus w bar yz. So w bar xz can be neglected. Gate number 3 is the redundant gate. How I have done? Y bar. The remaining part ka product is available here. This is what I told as consensus law. You can neglect the remaining. AB plus A bar C plus BC equal to AB plus A bar C. So Y bar. The remaining product is available. Neglect it. Otherwise, you can draw the K-map also. W, X, Y, Z. Okay. What is that? X, Y bar, Z. X should be 1, Y bar, Z. W bar, YZ. So W0, YZ. W bar, XZ. W bar, X, Z should be 1. Now which one is redundant? This is the redundant term. Because this is a pair, W bar, XZ. Is it clear? This is a pair. This is a pair. This middle one is the redundant, which is W bar X into Z. You can draw the K-map of the expression and find the redundant also. That is also correct. Copy it. See, remaining questions you can do for practice, which I have given some questions for your practice. You can try those questions. Now, let us see the last question of the chapter, question number 24. Read the question number 24. He has given some expressions like this. He is asking the value of A, B, C. Okay. Now listen. A plus B equal to 1, AC equal to BC, A plus C equal to 1, AB equal to 0. Now see here. In the first and last equation, A plus B equal to 1 and A into B equal to 0. From these two I can say AB should be either 0, 1 or 1, 0. It cannot be 1, 1. It cannot be 0, 0. Right? Because it will not satisfy both the equations. Now, here, very important, AC equal to BC, don't cancel C and say A equal to B, wrong answer. Okay, because C can be 0, because 0 into anything is 0. Now, if you take AB equal to 0, 1, then AC, what is that? 0 into C equal to BC, 1 into C. So, 0 into anything is 0 equal to C. Then he is saying A plus C is 1. A is how much? Here I have taken A 0. 0 plus C equal to 1. It is saying C equal to 1. Wrong answer. So A must be 1. B must be 0. Okay. Then A plus C equal to 1. And what is that? I'm sorry. A into C equal to B into C. So 1 into C equal to 0 into C, C equal to 0. That's all. So use the given info. One important point we should understand is AC is not B equal to BC doesn't mean A equal to B. Okay, we'll continue in the next lecture. That is about your Boolean algebra and K-maps.